All right, this is lesson 3, piecewise defined functions. Our essential question is, how do you model a situation in which a function behaves differently over different parts of its domain? Okay, so here's our table of contents. This is what we'll be discussing throughout this lesson. Define a piecewise function. So a piecewise defined function is a function that is built from pieces of different functions over different intervals. So it has different rules for different parts of its domain. So notice that there are both open and closed circles. A closed circle means that the point is included. An open circle means the point is not included. So to be considered a function, a graph can't have more than one x value paired with a y value. So if you look at this graph right here, the bottom, the y equals x squared, has an open circle, y equals 2 is a closed circle, and y equals x plus 2 is an open circle. This still remains a function. It's a piecewise function, but it still remains a function because each input has only one output. Okay, so if either this x plus 2 or this y equals x squared function would both have a closed circle with that y equals 2, then it would not be considered a function, since there are multiple points where x would have multiple y values. So when we write this function, we would write the rule and the domain that each function had. So remember to look at the closed versus open circles. And so we're going to really look at our domain. So from -2, my x value of -2, until I get to an x value of 1, which is not included, the function that I'm looking at is an x squared function. At y equals 2, I'm looking at just 2, and that's when x equals 1. And from x, so for the function x plus 2, or the line x plus 2, I'm looking at that from 1 until 2. So my x value is from 1 to 2. Okay. So again, I'm dealing with my x values. I'm looking at the graph of my function and then the x values that it's over. Model with a piecewise defined function. So example, Grace works at a fast food restaurant where she makes $10 per hour for up to 40 hours each week. If she works more than $40 per hour, she makes overtime, which is time and a half, which is $15 per hour. How could you make a graph and write a function that shows Grace's weekly earnings based on the number of hours she worked? Okay, so the first thing that I want to do is I'm going to make a table, because by making a table, I can visually see how much money she's making. So if she works 10 hours, she gets paid $100 because it was $10 per hour for 10 hours. Okay, so $10 times 10 gives me the 100. For 15 hours, she gets 150, so on and so forth, until she gets to 40. At 40 hours, anything above 40 hours a week, she makes time and a half for. So for 45 hours, she makes her $40 base pay, which is $400. And then she also gets paid $15 for each additional hour she works. So she worked 5 additional hours of overtime. So 5 times 15 gives me that $75. That's where I get the $475 from. Okay. Next, I want to graph some of the points. Okay, so I took the table that I had and I graphed my points. Okay, so I've got hours worked in my X's and how much she earned in dollars. And you can see that there's 2 different lines here. There's 2 different slopes of a line. From 10 to 40, she would have worked a specific amount and earned a specific amount for every hour. After 40 hours, she would earn more money. Okay, so now I can create the functions. I can notice that I have 2 distinct linear functions. I have 2 lines. Okay, so the first function, Grace working 40 hours or less, would be the amount of money paid per hour multiplied by the number of hours. So it would be 10h or 10x or 10z or whatever variable you would like to use. We used h because it's hours. Okay. The second function, when Grace is working her overtime hours, is her base price, the amount that she would get if she worked just 40 hours, okay, plus the $15 she worked for each additional hour minus 40. So if she worked 45 hours, we would put 45 in for H, and we would get that 5 hours of overtime she worked plus the 40. Okay. And then we simplified that. We multiplied 15 times H and 15 times 40, and then simplified it. So we got 15H minus 200. So that's my new equation for that pink line. Okay. Then I'm going to write my function. I'm going to write my piecewise function. I always start with y equals, and then I have the big curly brace. The big curly brace goes through all of my functions. So if I had 20 functions there, it would cover all 20 of those functions. Okay. And then usually you start from left to right. So whichever function that you create first. So in this case, the blue function and then the pink function. So 10H, and it's 10H between 0 hours and 40 hours. Okay. 40 is included in this because if she works 40 hours a week, she makes the $400. She doesn't make overtime. Okay. And then 15H minus 200 for H is less than 40. Okay, so any hours over 40 she worked, she would get that extra amount. Okay, graphing a piecewise defined function. Okay, so how do I graph a piecewise defined function? I want to graph x squared between -2 and 1, 2 at x equals 1, and x plus 2 between 1 and 2. All right, so step 1 is to recognize how many pieces I have. I have 3 different functions, so I have 3 pieces, okay? Now I'm going to look at my first function. The first function is x squared from -2 to 1, okay? We can see that -2 is not included, but 1, or is included, but 1 is not, okay? So I'm going to create a table for my first function. I'm going to substitute this value, -2, into my x and solve. So -2 squared gives me 4. I'm going to do that for each of my values until I get to 1. You don't have to do this for every single function every time that you do it, but it's a good practice to get into, especially when you're starting out with piecewise functions. Okay. So I'm going to do -2, -1, 0, and 1. I'm going to use all of those numbers so I have points on my graph that I can actually physically plot on the graph to graph this particular piecewise function. So I have -2 equals 4. When my x is -1, my y is 1. When my x is 0, my y is 0. And when my y is 1, when my x is 1, my y is 1. Okay. So I'm going to graph the first function based off of the table. Okay. So this is the first function that I'm graphing. Okay. And I can notice I start with a closed circle and I end with an open circle. Okay. Now I'm going to look at my second function. Okay. The second function is x at 1. We can see that this is the only number that's included. So it makes my life super easy. When my x is 1, my y is 2. I can create a table, and then I can graph the second function based off of that table. So it's going to look very similar to something we did. It's included. So that means that point is a closed circle on my graph. Okay. Now I'm going to look at my third function. Okay. This third function is between 1 and 2. Okay. So again, I'm going to create a table for that third function. I substitute my values in for x. So 1 and 2. In this case, 1 plus 2 gives me 3, and 2 plus 2 gives me 4. Okay. Notice that 1 is not included, but 2 is. Okay, so I'm going to graph my third function based off of the table that I have. Okay. And then I've got my graph here. So I plotted a point at 1, 3, and I plotted a point at 2, 4, and I connected them. Notice that the 1 is an open circle, but the 2 is a closed circle. All right, write a rule for a piecewise defined function. Okay, so I want to write a rule for this function right here that I have. Okay, notice that there are 3 different pieces. So I have this blue at the bottom, this red, and then this purple. Okay, a blue, a red, and a purple. I wanted to determine my domain for each of my segments. So the blue starts, again, I'm looking at my x values. My blue starts at -2 and it ends at 1. Okay. There is a closed circle at -2, which means that point's included. And there's an open circle at 1, which means it's not. Okay. My red starts at 1 and ends at 5, and they both have closed circles. And then my purple starts at 5 and ends at 8. 5 is open, 8 is closed. Okay. Now I'm going to find the slope of each segment. So the nice thing with this is we're dealing with linear functions. We're not dealing with parabolas. We're not dealing with quadratics or absolute values. We're dealing with linear functions, which means we can find the slope of the line. Okay, so I'm going to find the slope of each of these lines. I'm going to take the first point and the last point. I'm going to use those. Okay, I'm going to do y2 minus y1 over x2 minus x1, and I'm going to find the slope for each of these equations. So my blue equation, my slope is 3. My red equation, my slope is 1. And my purple equation, my slope is 0. Now I'm going to write those equations. So I pick a point for each of the segments and substitute that value of x and y into the equation along with the slope, so I can find where the y-intercept would be. The nice thing is this blue function, we already have a y-intercept, which is kind of nice. It's at -4, which it does end up being -4. Okay, but again, I can pick any point that I want. So I picked 1, -1, or -1, which is right here, that open point. Okay. And I substituted those values in. I found B, which was -4. I could have also just looked at the graph for that one. Okay. For the red, it has a slope of 1. So again, I can continue to look at the graph and realize it's going to cross at +3. Okay. But if I don't know that, I can use any one of these points on my graph. I can substitute them in. I used 1, 4. So I substituted 4 in for y, 1 in for x. I already had my slope. Solve for b, I got b equals 3. Okay. My slope is 0 for my purple line. So I'm going to, again, pick points. I picked 5, 8. You could pick 8, 8. You could pick 7, 8. It doesn't matter as long as it's on that line. I substituted the values in for x and for y, and I solved. B gave me 0. Okay. So B gave me 8, which is where it's going to cross over the y-axis. So now I have my equations for my blue, my red, and my purple. Okay, and now I'm going to put those into a piecewise function. So now I'm going to write this rule. I combine all of those equations from step 4 with the domains of step 2. Remember to take into account the closed and the open circles. So remember those equal bars underneath your values. Okay, so it's 3x minus 4 from -2 to 1, x plus 3 from 1 to 5, and 8 from 5 to 8. Write a rule for an absolute value function. Example, how can you rewrite the function f of x equals the absolute value of 6x plus 18 as a piecewise defined function? Write the function in the form a times x minus h plus k to find the vertex. So I start with 6x plus 18. I can take a 6 out of both 6x and 18, which gives me 6 times x plus 3. And then I can rewrite the plus 3 as minus -3. Okay, my h value is -3. My k value is 0. hk is my vertex. Okay, so the graph has 2 linear pieces, one to the left of x equals -3 and one to the right of x equals -3. Okay. Next, I'm going to determine the slope of an equation from each piece of the function by testing values on either side of x equals -3. Okay, so I'm going to choose a point that's less than -3. I chose -4. You can choose -10 if you want to. Okay, so I'm going to pick that point. I substituted it in and I found my y, what my y would be. Okay. So again, I find my slope, y2 minus y1 equals 6 minus 0, which equals 6, and x2 minus x1, which gives me -1. So my slope is -6. Okay. And then y equals -6x plus 18 is my equation, my first equation. Okay. Then I'm going to choose a point on the other side, so that's greater than -3. So x equals 0. Again, you can choose any point that you want. Okay. So it ends up being, if I put 0 in, I get positive 18. Okay. So then I substitute those points in. I have 0, 18 as my point. My other point that I used was that -3, 0 point. Okay. So again, I find my slope. 18 divided by 3 gives me 6. So I have y equals 6x plus 18. Okay. So next I can write the piecewise defined function. So I have -6x minus 18 and then 6x plus 18. It doesn't matter which version or which one you put the equal sign under, just make sure you only put it under one equal sign. Otherwise, it's technically not a function. Okay. And then you're going to confirm with graphing. So I could have done x is less than or equal to -3 and x is greater than 3, or I could leave it like this. Again, either way is fine. It's going to give you the same answer. It's not going to be wrong one way or the other, but just make sure you only put the equal sign under one option. All right, step functions. So step functions are called step functions because they are piecewise functions, but they look like steps. So it pairs every input in an interval with the same output value. So notice that they all create straight horizontal lines. So I could have a floor function where my lower value is the one that's included and my higher value is not included. I could have ceiling functions where my lower value is not included and my higher value is included. Or I could kind of have a mixed bag, which is what this one is over here. So I've got A, where I've got B, C, D, and E. Okay. So if I want to graph a step function, okay, so the shipping cost of items purchased from an online store is dependent on the weight of the items. The table represents shipping cost, Y, based on the weight, X. Graph the function. What are the domain and range of the function? What are the maximum and minimum values? So again, from 0 to 2 pounds, it cost me $5 to ship that box, okay, that item or whatever the case may be. It could be anywhere between that 0 and 2 pounds. It can't be anything less than 0 because of the fact that if you have something that weighs less than 0, it's not there. Okay. And then you've got 2 to 4 pounds, 4 to 6, and 6 to 8. So the top are my X values. That's my domains. Bottom are my Y values, my ranges. Okay. So using that table, I can then graph my function. So notice that the far left side of each of the circles is an open dot and a closed dot on the far right side of the circle. Okay. So from 0 to 2, where my X values are 0, 1, or 2, or anything in between there, it's going to be $5. Okay. When my values are between 2 and 4, it's $8. When my X values are between 4 and 6, it's $11. And when my X values are between 6 and 8, it's $14. So my domain includes everything from 0 to 8 pounds. Okay, so that's the domains included. Okay, 0 is not included because, again, you can't have a package that weighs nothing. My range is specific numbers. It's not a range of data like my domain is. It's the specific shipping costs for each one. There is no way that you will have a range that's from 5 to 14. Okay. Your values are 5, 8, 11, and 14. I'm not going to have a package that's $5.50 or a package that's $11.25. Okay, I'm only going to have packages that are $5, $8, $11, or $14. Okay, so there is a minimum, my smallest value at 5. Okay, and there is a maximum at 14. Okay, so again, a piecewise function has different rules for different parts of the domain. So again, here's what a piecewise function could potentially look like. Piecewise functions really can look like pretty much anything, and they can involve hundreds of different sections, or they can involve 1 or 2. Okay, so these are what piecewise are. And that is the end of lesson 3.